Hello everyone, I'm Naveen Shankar Choudhury, a student from VIT Chennai, and today I'll be explaining synchronous motor. I'll be explaining about the construction of synchronous motor, the working principle of synchronous motor, and the types of synchronous motors. Yes, so what is a synchronous motor? A synchronous motor is an AC motor wherein, at steady state, the rotation of the shaft is synchronized with the frequency of the supplied current. The rotation period is exactly equal to an integral number of AC cycles. These motors contain multi-phase AC electromagnets on the stator of the motor that create a magnetic field that rotates in time with the oscillations of the line current. A synchronous motor is doubly fed if it is supplied with the independent excited multi-phase AC electromagnets on both the rotor and the stator. Here is some of the pictures and images of the synchronous motor. Next, coming to the construction of synchronous motor. The construction of a synchronous motor is just like any other motor. It consists of a stator and a rotor. The stator core is constructed with thin silicon lamination and insulated by a surface coating to minimize the eddy current and the hysteresis losses. The stator has axial slots inside in which three-phase stator winding is placed. The stator is wound with a three-phase winding for a specific number of poles equal to the rotor poles. The rotor in synchronous motors is mostly of salient pole type. DC supply is given to the rotor winding via slip rings. The direct current excites the rotor winding and creates electromagnetic poles. In some cases, permanent magnets can also be used. Apart from stator and rotor, the synchronous motor also consists of exciter and frame. Exciter is a small generator placed in the rotor, which provides excitation power for excitation. It consists of a field winding and armature winding. The field winding is placed in stator and armature winding is placed in the rotor of the machine. Frame protects the motor and covers the whole assembly. Now, next, coming to the working principle. The operation of synchronous motors is that rotor follows the rotating magnetic field of a stator and rotates at a speed approaching it. The rotor winding is excited by a DC source and the stator winding is excited by AC source. The salient points regarding the working principle of synchronous motor are: due to three-phase AC, a three-phase rotating magnetic field is produced by stator winding. Rotor winding produces a constant magnetic field. At some rotation, the poles of two magnetic fields attract each other, while at some instant they repel each other. The rotor will not start to rotate due to its inertia, so an external source will provide initial rotation. Once the rotor starts moving at the synchronous speed, the external source is shut off. The magnetic field of a rotor is not produced by the magnetic field of the rotor, but through induction. Hence, the air gap between rotor and stator is not kept very small. Now next, discussing about the types of synchronous motors. The synchronous motors can be classified into two types based on how the rotor is magnetized. One being non-excited synchronous motor and the other one being direct current excited synchronous motor. First, talking about non-excited synchronous motors. In this type, the rotor is made of high rentatively steel such as cobalt steel. At synchronous speed, it rotates with the rotating magnet of the stator, so it has an almost constant magnetic field through it. Due to the field interaction of the stator with the rotor, it becomes an electromagnet and it has north and south poles that interact with stator field poles in this way, which makes the rotor move. This type of synchronous motor is divided into three categories and is available in three designs, each one of them having its own unique features. One being hysteresis synchronous motors, the next one being reluctance synchronous motors, the third one being permanent magnet synchronous motors. Now, talking about the types of non-excited synchronous motors. First, hysteresis synchronous motors. The hysteresis motors are single-phase motors with a rotor made of ferromagnetic material. The rotors have high hysteresis loss property. This has a wide hysteresis loop, meaning once it is magnetized in a given direction, it requires a large reverse magnetic field to reverse the magnetization. Second, the reluctance synchronous motors. The second design of non-excited synchronous motors is reluctance, which is always minimum when a piece of iron rotates to complete a magnetic flux path. The reluctance increases with the angle between them when the poles are aligned with the magnetic field of the stator. This will create a torque pulling the rotor into alignment with the pole near the stator field. The third one being permanent magnet synchronous motors. The permanent magnet motor uses permanent magnets in the steel rotor to create a constant magnetic flux. The rotor locks in when the speed is near synchronous speed. The stator carries winding, which is connected to an AC supply to produce a rotating magnetic field. Permanent magnet motors are similar to brushless DC motors. Now, in this slide, we can see some of the images of the non-excited synchronous motors, which we had discussed in the previous slide. The three of them being permanent magnet synchronous motors, hysteresis motor, and reluctance synchronous motors. Now, talking about the next type, which is direct current excited synchronous motor. DC excited synchronous motor, as seen in the first image here, requires a DC supply for the rotor to generate a magnetic field. It has both stator winding as well as rotor winding. The direct current can be supplied from a separate DC source or a DC generator connected to the motor shaft. They can either have cylindrical rotors or salient pole rotors. They are not self-starting and need damper windings to start. Initially, they start as an induction motor and later attain synchronous speed. Thus, I would like to end the discussion right now. Thank you so much for listening to me patiently. Thank you.